Okay, here's an object that I happen to have close at hand. So I'm not going to turn it over because the liquid will fall out. So it's going to have to be a cone with the pointy tip down here. And if you can imagine that the sides of this kept going down so that we had a full cone, but this is kind of sliced at one height and then sliced again at another height. I'm going to try to make up some math equations that correspond to my cup. So let's call this, oh, it's even steeper than that. Okay, well, it's close enough. So I'm going to call this y equals 5x. And I'm going to imagine that this is y equals negative 5x. So I didn't draw them quite as steep as my cup, but that's easily fixed. Okay, my cup fits in here, more or less, and I'm going to say that the cup part runs from y equals 4 up here to y equals 10. Well, you can see that for this part of a cone, if I were to take cross sections that were perpendicular to the y-axis, so take my cross sections like this, then each of those cross sections would be a circle. They'd be bigger and bigger circles as we went up. And if I think about this arbitrary cross section that I might select, I know that the volume of that cross section is going to look like the area of the circle times the thickness of dy. Well, the area of our circle, again, that's pi r squared. Our thickness was dy. And looking at these, in order to get the volume of just the part of the cone where my cup is, between 4 and 10, I'd be taking those slices from y equals 4 up to y equals 10. So in terms of an integral, I'd be integrating from 4 to 10. Now, this gets back to the same sort of radius dilemma that we had in the previous problem, which is I'm about to try to integrate something with respect to y. So I can't leave an r in my equation. I need to write my radius in terms of the variables in the problem. Well, if I come over here, although I gave us both the function y equals negative 5x and the function y equals positive 5x, I only need one of those to come up with the radius. And this radius in the picture, it's not the y value, it's actually the x value. If I take this y equals 5x and rearrange that to be x equals y over 5, that will correspond to the radius at any given height. Now, plugging that back into our equation, I'd have the integral from 4 to 10 of pi. I don't really need the parentheses there, and I think it's going to get messy. So I'd have my pi, and our radius here was y over 5, whole thing squared, dy. And then if we wanted to simplify that a little bit, 5 squared would be 25. So I could pull out pi over 25 out in front of that integral, and I would just be left with y squared dy.